Hi everyone, this is AP Calculus 4.2 and today we're going to talk about straight line motion. And in straight line motion we talk about connecting position, velocity, and acceleration. In straight line motion, or really any motion problem that you have, your position function is going to be stated as s of t, p of t, x of t. Those would all be different ways of expressing your position function. Your velocity function is v of t, and that stands for velocity, obviously, and velocity is the derivative of your position function. So whether you use s of t, p of t, or x of t, s prime of t would be velocity. P prime of t would be your velocity, and x prime of t would be your velocity. So basically, your velocity is the derivative of the position function. Acceleration is the second derivative of the position function. So acceleration is usually used, we usually use a of t for that. That is the same thing as the first derivative of your velocity function or the second derivative of your s of t, p of t, or x of t. Those are all different notations that we could use. Usually position, for most of them that I've seen, we use s of t, but these other two are common as well. Usually velocity, most people use v of t, and acceleration, a of t. It's understood that v of t is the derivative of s of t, and a of t is the derivative of v of t, or the second derivative of s of t. So those are all things that you need to understand as you're moving forward with velocity. For the position function, to understand what it means, the position is the distance an object is from the starting point. Now, that does not mean that's the total distance traveled over a period of time. It's the actual physical distance from the starting point of your object. So if it started at 0 and at time t equals 10, it's 5 feet away from 0. That does not mean that it's just traveled 5 feet. That means that it could have traveled 10 feet and then gone back 5 feet, and that's where it is at time 10. So it does not mean it's the total distance traveled. That's a common misconception. So understand that the position is just at a specific time how far an object is from the starting point. It does not mean that's the total distance traveled. The velocity, v of t, which is s prime of t, p prime of t, or x prime of t, is the rate of change of an object. The rate of change, remember, is measured in length over time, which is something we talked about in the last section. That's your change in y over your change in x. And the units is usually going to be in miles per hour, feet per minute. Remember that one problem we did in the last section, skittles per minute. So it's the object, the change in the number or the position of the object over the amount of time. For acceleration, that's whether the object is speeding up or slowing down. And your units is the velocity over time. So if your velocity is miles per hour, then you would have miles per hour because it's the velocity over the time. An object is going to be speeding up when the velocity and acceleration have the same sign. That's one misconception that students have a lot. They think if the velocity is positive, then that means acceleration is speeding up. That's not true. Acceleration is only going to be speeding up if velocity and acceleration have the same sign. And then the opposite of that is also true. An object is slowing down when the velocity and acceleration have different signs. So just because the velocity is positive does not mean it's speeding up, and some students have a hard time with that. So a velocity is, or an object is speeding up when the velocity and acceleration have the same sign, slowing down when the velocity and acceleration have different signs. When we're talking about speed of an object, if it's a straight line motion or if it's up and down motion, it doesn't matter. The speed is always going to be the absolute value of the velocity. And we need to talk about the velocity and whether it's positive or negative, because there are a couple things that we can tell based on whether velocity is positive or negative. In straight line motion, which is what we're talking about in this section, if v of t is greater than 0 or positive, then the object is moving to the right. If v of t is less than 0 or negative, the object is moving to the left. And if v of t is equal to 0, that means the object is at rest. Now, similarly with up and down motion, like if we were to throw a baseball into the air or something like that, if v of t is greater than 0, that means the object is moving up. If v of t is less than 0, that means the object is moving down. And if v of t is equal to 0, that means the object is at rest. So if I just do a real quick demonstration here of what that would look like. Let's say I have a ball and it's on the ground right now. So here's the ground. And we'll pretend like that's straight. And the ball starts off here. And we have some sort of force pushing the ball into the air. So the ball goes up and it's going to travel so much time, however long it is, until it hits the ground again. So if you think about that ball being thrown up and back down, or it could be any object being thrown up and back down, it's going to have a basic shape of a parabola. And if we think about the velocity of that ball, when it's thrown at first, the velocity is moving up in that direction. So if you think about the slope of the tangent line there, anywhere up in this area, the slope of the tangent line is going to be positive, which means the derivative is positive, which means the velocity is positive. If you think about the slope of the tangent line at the highest point right here, if the maximum spot where that ball hits its maximum height, the maximum height from the ground up, see, that is where the object is at rest, or the slope of the tangent line is 0. And then if you think about the object or the ball going on this side, the velocity or the slope of the tangent line is negative. But we have to think about speed. We know speed can't be negative. Speed has to be positive because it doesn't make sense for something to have a negative speed. So that's where the absolute value of velocity comes in for our speed. If the velocity is positive, that means the speed is positive, but that just also tells us that the object is moving up. If the velocity is 0, that means the object is at rest, or it's the horizontal tangent line, the highest or lowest point on the graph. If the velocity is negative, that means it's moving down, but understand the speed is not negative, the speed is still positive, it's just moving in a downward direction. And the same thing is true for straight line motion. If we have an object, let's say that we have a marble or something here, and we move the object here, and let's say it goes for 2 or 3 seconds that direction, and then it stops, maybe it hits a wall or something here, and then it travels to the other direction, and then maybe it hits something and then it travels in the other direction. Well, if you think about that, and eventually it'll stop, right? If you think about that ball or marble being thrusted back and forth like that, the total distance traveled would be this distance from the beginning plus this distance plus this distance again until it eventually comes to a stop. So you need to understand that position is not the total distance traveled. And if we think about this, I'm just going to draw a little diagram here. So let's say we have some sort of a track here. And let's say there are a couple of walls, or maybe just boundaries for that track. Okay, so let's say I have a marble, and that marble starts right here on the track. And the initial force of the marble is forcing that marble to the right in this direction. Well, the velocity, when it's traveling in that direction, is going to be positive. Then it hits this boundary, and that marble goes back in this direction again. So let's say it goes all the way to the next boundary right here, and then when it hits that boundary, the marble goes back again this direction, and then it comes to a rest, or it comes to a stop. Well, if this was the initial starting point, wouldn't the total distance traveled from the beginning to the end of the problem be this distance plus this distance plus this distance? But the object is at rest at the beginning of the problem. It's at rest here when it changes direction. It's at rest again here when it hits this boundary and changes direction. And then it's at rest again here when it just loses momentum and stops. So we can't say that P of t, like let's say this whole scenario took 20 seconds. We can't say that P of 10 is the total distance traveled, because if this took 5 seconds and then it takes 5 seconds to get back here, the total distance traveled would be this distance plus this distance. So the position of an object is just the position of where from the, it's just the distance an object travels from the start position until where it is at that particular time. If we want to think about the total distance traveled, we have to talk about where the resting spots are, whether it was traveling in a positive direction or a negative direction when those traveling places are at rest. And then we have to think about the position those things were when those objects were at rest and add those different distances together to get total distance traveled. So that's something we'll talk about as we move through this unit. So here's my first example. The position function is given by s of t equals 3t squared plus 2t plus 5, where s is measured in meters and t is measured in seconds. Find the velocity when t equals 2, and then find the acceleration at t equals 2. Is the object speeding up or slowing down? Well, first they ask us to find the velocity. So if I find the velocity, I'm going to take the derivative of this function. The derivative of that function is pretty simple, 6t plus 2. If they're asking us to find the velocity when t equals 2, they want v of 2. That means we plug 2 into the velocity function. So that would be 6 times 2 plus 2, which is 12 plus 2, or 14. We have to make sure we include the unit of measure. And if the velocity at 2 is 14 and the units of measure were meters for the length and seconds for the time, that would be 14 meters per second. And if I were taking the AP test and I had a problem like this, I would make sure to use all of this notation when I'm going, just to make sure that I'm getting all of those points that I need. Find the acceleration at t equals 2. Well, for acceleration, a of t, we need to find the derivative of the velocity function. Well, that would just be 6. So that means a of t is 6. There is no variable here. So doesn't that mean that a of 2 is also 6? No matter what the time, the acceleration is 6. So what they're asking us in the end here is the object speeding up or slowing down? Well, look at your velocity. V of 2 is greater than 0. Look at your acceleration. A of 2 is also greater than 0. Since these two things have the same sign, they're both positive, that means that the object is speeding up. A particle moves about the x-axis so that at time in seconds t is greater than 0, its position in feet is given by x of t equals 2t cubed minus 21t squared plus 72t minus 53. Part A says, at what t value is the particle at rest? B, when is the particle moving toward the left? And C, at v of 2, is the particle speeding up or slowing down? So part A, if I just do part A right here, at what t value is the particle at rest? Okay, we know a particle is at rest when its velocity is equal to 0. So what we need to do is we need to find the velocity function first. So if I do that, I have 6t squared minus 42t plus 72 as my velocity function. If they're asking us when the particle is at rest, they're asking us when is the velocity equal to 0. So I'm going to take that 6t squared minus 42t plus 72, and I'm going to set it equal to 0. Then I'm going to factor to figure out what the t values are when this velocity is equal to 0. I can take out a 6, so if I divide everything by 6 here to get rid of it, that'll make my factoring easier. T squared minus 7t plus 12 equals 0. So now, what factors of 12 will add to give you 7? Well, that would be 3 and 4. So we've got 3 here, 4 here. They're both minus. If we set those equal to 0, I have t equals 3 and t equals 4. So if I'm talking about this using units of measure, the particle is at rest at 3 seconds and at 4 seconds. So that is the answer for part A. It's at rest at 3 seconds and 4 seconds. For part B, when is the particle moving toward the left? Okay, if these are the two places where the particle is at rest, basically what that means is, and we know this is straight line motion, if I just do kind of a timeline here, that's at 0 seconds. Let's say this is at 3 seconds and this is at 4 seconds. We don't know what happens to this direction, but we know that these are the places where the particle is at rest. So if we're trying to figure out whether the particle is moving to the right or to the left, then couldn't we plug in a value between time 0 and time 3 to figure out if the particle is moving right or left? And put in a time or a value between 3 and 4 to figure out if the particle is moving right or left. And we're going to plug this into that velocity function right here. So if I use the velocity function, and I'll just pick here, I'm just going to pick at 1 second. I know it's at rest at 3 and it's at rest at 4, so it's going to be traveling in the same direction here, either left or right, and the same direction in this interval, either left or right. So I'm going to plug in something between 0 and 3, 1 second, and something between 3 and 4, I'll just say 3.5 seconds. And I'm going to find V at 1, and I'm going to find V at 3.5 and see what happens. Well, if I plug 1 into the velocity function, I have 6 minus 42, which is negative 36, plus 72. Well, at 1 second, it's positive. So that means at V of 1, it's positive. So if it's asking me when is the particle moving toward the left, well, it's not moving toward the left here in this interval. It's moving toward the right. Let's look at V of 3.5. For V of 3.5, I'm going to want to use a calculator for this. And I got negative 1.5. So that means the particle is moving to the left from the interval 3 to 4. So when it says when is the particle moving to the left, my answer for that would be the object is moving left when my time is between 3 seconds and 4 seconds. I don't put equal to because remember at 3 and at 4 the object was at rest. So it's not when it's less than or equal to and less than or equal to, it's just less than for each of those. And then for part C, it says at V of 2, is the particle speeding up or slowing down? Well, at V of 2 is in this section right here, we know that V of 2 is greater than 0. So then what else do we need to find for whether it's speeding up or slowing down? Well, we need to look at acceleration. So I'm going to go back up here to the initial velocity function, and I'm going to find the acceleration function. So the acceleration function is 12t minus 42. And if we're looking for acceleration at 2, well, that would be 24 minus 42. And 24 minus 42 is negative 18, so A of 2 is less than 0. So look at our signs here. The velocity here is positive. The acceleration is negative. When velocity and acceleration have different signs, the object is slowing down. And that's the end of that problem. So just to recap real quick, if the velocity and acceleration at a specific time have the same sign, then the acceleration is speeding up. But if the velocity and acceleration have different signs, one's positive and one's negative, like in this situation, the object will be slowing down. And that's something that you need to memorize, just understand that that is always the case, so that whenever they ask you for that, you know what to do and how to answer that question.